question 2a. So in these questions, we can see that there is a circuit, and in this circuit, we have an alternating current supply. This is a symbol for alternating current supply. And then is labeled that the VRMS, the root mean square voltage of this alternating current supply is 240 volt. And then there's a resistor. The resistance is 50 ohm. So the figure shows that a load is connected to an alternating current. The load is the resistor, okay? So the load is connected to an alternating current supply with a root mean square voltage of 240 volt. What is alternating current? Okay, so they want us to tell the definitions of alternating currents. Okay, what is meant by alternating current? So by definitions, an alternating current is a current which changes its directions periodically in a circuit. So alternating currents is a current that keep on changing its directions. Okay, so let's say initially the current move clockwise, and then it will move counterclockwise, clockwise, counterclockwise, clockwise, counterclockwise. Okay, alternating current is a current which changes its directions periodically in a circuit. So that is the definitions of alternating current. Question 2b, state 3 differences between alternating current and direct current. State 3 differences between alternating current and direct current. In structured questions, if they ask about differences, you can draw a table. In essay question also, if they ask about differences, also you can draw a tables. Actually, you are advised to draw a tables to present your answer. So they want 3 differences between the alternating currents and direct currents. So we draw a table, these direct currents, alternating currents. First, we tell about the directions of the flow. Okay, so direct current, it flow in one direction only, but alternating current, it flow to and fro periodically. For direct currents, it can be displayed on a cathode oscilloscope, and then normally it's a straight line. Normally it's a straight line in this cathode oscilloscope. So usually in cathode oscilloscope, for direct currents, you will see something like this. It's a straight line. But for alternating currents, in a cathode oscilloscope, you will see the sinusoidal waveform. This is called a sinusoidal waveform. In direct current, you will see a straight line in cathode oscilloscope, and alternating current, you will see a sinusoidal waveform. Okay, normally, but not absolutely. Normally, it's like that. We will discuss displays of cathode oscilloscope next week. And then the third thing is effect on capacitor. So direct current, it does not flow through capacitor, but alternating current, it can flow through capacitor. We will also discuss a capacitor under electronic. Okay, how capacitor functions. We will discuss that under electronic. And the last one is effect on moving coil loudspeaker. Do not produce vibrations in loudspeakers. Direct currents, okay, it will not produce vibrations in loudspeakers, but alternating current, yes, it will produce vibrations in a loudspeaker. Vibration means it will produce sound. If you connect direct currents to a moving coil loudspeaker, no sound produced. But if you connect alternating currents to this moving coil loudspeaker, then it will produce sound. If we give difference in number of carbon brush, okay, that is the direct current generator and alternating current generator, Atika. But this one, they just want you to tell the difference between direct current and alternating currents. What you tell is the difference between direct current generator and alternating current generator. But even for the generator also, if you tell the number of carbon brush is also not correct. Okay, you must either tell that direct current generator has a split ring commutator, but alternating current generator has 2 slip rings. So don't tell the number of carbon brush because that is not important. Okay, number of carbon brush is not important. So these are the differences between alternating currents, and because this one just 3 differences, so you can just write 3 of it. So I give all of it, But in exam, because they ask about 3 differences, then you can just give 3. Yeah? 2C, what does it mean by a root mean square voltage? Okay, or VRMS. Any idea? Do you still remember what is root mean square voltage? So the root mean square voltage of an alternating current. So root mean square is always for alternating currents. Okay, we don't have root mean square value for direct currents. So root mean square voltage of an alternating current is the values of the voltage which would produce the same heating effect. Okay, same heating effects as the voltage of the same value direct steady currents. Means what? Means if you have 2 bulb. Okay, you have 2 bulb. So the first one you connect to alternating currents, and the second one you connect it to a direct currents. If the alternating currents, the root mean square voltage is 240 volt, and the direct current only voltage, you don't have root mean square voltage, just a voltage. The voltage is 240 volt. Okay, so if the root mean square voltage is 240 volt, then the heating effect will be the same as the direct current that has 240 volt. So therefore, these 2 bulbs will produce same brightness. Okay, it will produce same brightness. Okay, that this the root mean square is 240, but if you use the cathode ray oscilloscope to measure, you will find that the maximum voltage can be about 340 volt. The peak voltage can be 340 volt, but the root mean square is 240 volt. Then the brightness of the bulb produced will be exactly the same as the brightness of the bulb connected to direct currents 240 volt. So root mean square voltage of an alternating current is the values of the voltage which produce same heating effect as what? As the voltage of a same value direct steady current. Same value. This 240 volt, this also 240 volt. Okay. So that is the meaning or the definitions of root mean square voltage. 2C, what does it mean by a root mean square voltage? Okay, or VRMS. Any idea? Do you still remember what is root mean square voltage? So the root mean square voltage of an alternating current. So root mean square is always for alternating currents. Okay, we don't have root mean square value for direct currents. So root mean square voltage of an alternating current is the values of the voltage which would produce the same heating effect. Okay, same heating effects as the voltage of the same value direct steady currents. Means what? Means if you have 2 bulb. Okay, you have 2 bulb. So the first one you connect to alternating currents, and the second one you connect it to a direct currents. If the alternating currents, the root mean square voltage is 240 volt, and the direct current only voltage, you don't have root mean square voltage, just a voltage. The voltage is 240 volt. Okay, so if the root mean square voltage is 240 volt, then the heating effect will be the same as the direct current that has 240 volt. So therefore, these 2 bulbs will produce same brightness. Okay, it will produce same brightness. Okay, that this the root mean square is 240, but if you use the cathode ray oscilloscope to measure, you will find that the maximum voltage can be about 340 volt. The peak voltage can be 340 volt, but the root mean square is 240 volt. Then the brightness of the bulb produced will be exactly the same as the brightness of the bulb connected to direct currents 240 volt. So root mean square voltage of an alternating current is the values of the voltage which produce same heating effect as what? As the voltage of a same value direct steady current. Same value. This 240 volt, this also 240 volt. Okay. So that is the meaning or the definitions of root mean square voltage. Okay, find the peak voltage in the circuit. Okay, now the question tells us that the root mean square voltage is 240 watt, right? I think so. Let's check. Okay, so they tell us that the root mean square voltage, not this one. So they tell us that the root mean square voltage is 240 watt. So the root mean square voltage 240 watt. Can any of you tell me what's the formula of root mean square voltage? Vrms equals to what? Equals to the peak voltage divided by the square root of 2. So Vrms equals to Vp divided by the square root of 2. Now in this case, the Vrms is 240 watt. So 240 watt, okay. This root 2, square root of 2, we multiply to the left hand side. So then it will become 240 multiplied by the square root of 2 equals to Vp, the peak voltage. So then what's the values of the peak voltage? Yes, Vp equals to what? Okay, the answer is 339.4. Okay, 339. Okay, I think 339 is 339.4 or 339. Okay, wood. Because this one is 3 significant figure, so we give our answer in 3 significant figure as well. Okay, 339 wood. So that is how we find the peak voltage from the root mean square voltage. This is also the formula for us to find the root mean square voltage from the peak voltage. What is the values of the peak to peak voltage? Peak to peak voltage. Now, what is a peak to peak voltage? This is called a peak voltage. From the center to the maximum. Okay, just now it's 339, right? 339 watt. Okay. This is called a peak voltage, or this one also. Okay, it will be the same. 339 watt. 339 watt. Then what is VPP? Peak to peak voltage. Peak to peak voltage is from the bottom to the top. So this is called a peak to peak voltage. So the peak to peak voltage is equal to 2 multiplied by the peak voltage. The peak voltage is 339.4. 339.4. 2 multiplied by 339.4 is equal to 678. Okay, 678.8. 678.8. Okay, we can round up it to 679. Okay, 679 watt. Now you see, in these calculations, I use 339.4 instead of using 339. In previous slides, I get my answer 339. Okay, but this one I use 339.4. Why? Why? Because for final answer, your number of significant figure can be the same or should be the same as the number of significant figure that you of the numbers that you use, the value that you use in the equation. So this one, 3 significant figure. So this one we give 3 significant figure. But that is for final answer. That's for final answer. Okay. So for this one, so this is not the final answer. So if this is not the final answer, we should get a more accurate value. You should use a more accurate value. So you can use a 4 significant figure or even 5 significant figure. Okay, 339.4 or 339.41 for your calculations. Then only you will get a accurate answer for your this final answer. 2 times 339.4. Okay, so you get 678.8. Okay, or 679. If you use 339 only, then you will get 678. Okay, but the correct answer is 679. 679 words. So you see, you must be very careful. Okay, for not final answer, okay, you should use a more accurate value for the calculations. But for final answer, then you should use the number of significant figure same as the values that you use for the calculations. Okay, this calculation actually, the answer is come from the 240 watt. Okay, the calculation is come from 240 watt, and this one is 3 significant figure, and therefore this answer is also 3 significant figure. Okay, 2F, find the root mean square values of the current in the circuit. Okay, now I think just now we have done this in question A, yeah? Okay, question A. We use the formula V RMS equals to I RMS R, right? The V RMS is 240, I RMS we don't know, and R is 50. So therefore the root mean square current is equal to 4.8. So just now I told you that I misunderstood the questions, right? Because question 1 actually what they want is the definitions of alternating currents. And now they want the root mean square current. Okay, so we can find the root mean square current by using V equals IR. Okay, but for alternating currents, the V is the root mean square voltage and the I is the root mean square current. Find the power loss in the resistor. Okay, power loss in the resistor. For electric power, there are 4 equations or 4 formula that you can use for your calculations. Okay, the first one is the general formula of power. P equals to W over T, work done divided by time, or P equals to energy change divided by time. Then we have 3 more formula for electrical power. Can any of you tell me what are the formula? For electrical power, P equals to what? P equals to what? Other than P equals W over T and P equals to E over T, what other formula that you have? P equals to IV, yeah? P equals to IV, or P equals to I square R, or P equals to V square over R. So these are the 4 formula that we can use for our calculations. In these questions, I suggest that you use this one, okay? Because we know that the voltage, the V RMS is 240 volt, and the resistance is 50 ohm. So the power. Now, for alternating currents, the power that you use must be the root mean square voltage. To find the power, the voltage must be the root mean square voltage, and the current must be the root mean square current. You cannot use the peak currents to find the power. You must use the root mean square currents or the root mean square voltage to find the currents. So V RMS square over R, okay. The root mean square voltage is 240, and then we square it, divided by the resistance 50. So what's the power? 1152 watt. So make sure that you memorize all this formula, and make sure that you remember to find the power of alternating current, the voltage that you use, and the current that you use must be the root mean square voltage and root mean square current. So if you want to find the power by using P equals IV, then it must be P equals to I RMS times V RMS. So you cannot use the peak currents or the peak voltage to find your power. 2H, find the energy loss in the resistor in 1 minute. So the energy loss in 1 minute. Then this one we can use P equal to E over T. Yeah? Okay, E is the energy change. Yeah? Okay, in this case the energy loss energy loss to the surrounding. Then E equals to PT. E equals to PT. Yeah? Okay, and P is the power. And in previous questions we already find the power, right? The power is 1152 watt, and the time taken is 1 minute. But if you want to give your answer in joule, okay, then you must change this 1 minute to seconds. Okay, you cannot use 1 minute. So this is 60 seconds. 60 seconds. So 1152 multiplied by 60 seconds. So it's 69120 joule. Okay. Now the unit of power is watt. The units of power, the unit of power is watt. Okay, is watt. Watt is joule per second. Joule per seconds. Okay, so this is 1152 is watt. So if we use watt, okay, so this is in second. So then the time must also be in seconds. So we cannot use second, joule per second for power and then use minutes. Cannot. Okay, so the unit that we use must be consistent. So if we use watt, then the time must be in second, cannot be in minutes. If you don't know, you're not sure, then you always use the SI unit. The SI units of time is second. So if you don't know which one to use, then you always use SI units. Then it won't be wrong. 2I sketch the graph of voltage against time. Frequencies of alternating current is 50 Hertz. So to sketch the graph, first we draw the axis of the graph. Vertical axis, horizontal axis. And then you should know that the graph is a sinusoidal graph. Okay, for sinusoidal graph, okay, the maximum value at the peak voltage. The peak voltage is 339, right? So this is voltage, V, and the unit is watt. 339. 339. This is negative 339. Then the graph is a sine graph, a sinusoidal graph. Sinusoidal graph. I think you should have learned how to sketch the sine graph in math, right? Trigonometry. Okay, you should have learned how to sketch the graph. The sinusoidal graph is like this. And then they tell us that the frequency is 50 Hertz. 50 Hertz means that the period T equals to 1 divided by 50, which is equal to 0.02 seconds. 0.02 seconds. So this is time in seconds. So one complete cycle is 0.02 second. So this is 0.04. So one complete cycle or one complete oscillations, 0.02, another 0.02. So this is the graph of voltage against time for the frequency 50 Hertz and peak voltage 339 watt. But the root mean square voltage is 240 watt. Atika asked a question. Okay, P equals to E over T. P equals to W over T and P equals to E over T. Is it the same? A good question. Okay, P is W is work done. The W is work done, and the E is energy change. Right? Now, is it the same? Now, work and energy is not the same. Okay, but for calculations, actually they are the same. Why? Because we do work to cause the energy change. So the amount of energy change will be equal to the amount of work done. So for examples, if you do 20 joules work, you will cause 20 joules of energy change. If you do 30 joules work, you will cause 30 joules of energy change. So therefore, for calculations, yes, they are the same. Okay, but actually, work and energy is two different things. But for calculation, you can assume that they're the same because amount of work done will be equal to the amount of energy change.